Hello, this is the video on example 3 for geometry, topic 1, lesson 8. Writing an indirect proof by contrapositive. We just did one on contradiction, this is contrapositive. If you recall, the contrapositives when we say not Q implies not P, what we're going to do with this is it turns out that P implying Q and the contrapositive not Q implying not P are logically equivalent, so they have the same truth value. So if we can prove not Q implies not P, then we can conclude P implies Q. We're first going to start off with that the opposite of Q is true. That's going to lead us to the opposite of P, which shows us this and concludes with that. I think I just made it wordier than it was. Let's see if we can make sense with an example. For two positive integers n and m, if n times m is greater than 16, then either n or m is greater than 4, or they could both be greater than 4. That's the whole statement. So first let's write down the hypothesis, conclusion, and the opposite of those. The hypothesis was if n is greater than 16, and I'm having trouble highlighting that. Oh well, n times m is greater than 16. The opposite of that would be that n times m is less than or equal to 16. That's what we're going to conclude. And then Q, this part here, n or m is greater than 4, or both are greater than 4, can be written out mathematically like this. N is greater than 4, or m is greater than 4, or they're both greater than 4. So the opposite of all of them being greater than 4 is that n or m could be equal to 4 or less than 4. And that's what we're going to start with. We're going to start with that this part is true, that n and m are less than or equal to 4. Okay? Now, if n and m are less than or equal to 4, we can probably get to where we have the opposite of P. Let's take, for example, that n is less than or equal to 4. Well, if n is less than or equal to 4, then n times m would be less than or equal to 4m if we just replace the n with a 4. And if m is less than or equal to 4, we would have 4m is less than or equal to 16. Now we have the 4m in the both places, so we can combine that to say, we're using the transitive property that nm must be less than or equal to 16, and that's what we were trying to say. Okay, that's the opposite of P. I might have lost you at some point there. We started off with the opposite of Q, and we came to a logical conclusion that the opposite of P must be true. So since the opposite of Q implies the opposite of P, we can state that P implies Q must be true. Okay? Again, it'll make more sense with more practice. If you think you're okay, and this one isn't that mathy, it's got days of the week, click pause and try to do these two, and then push play to see how I did. All right, if today is Wednesday, then tomorrow's Thursday. I know I need to start with, I'm just going to jump right in and start with the opposite of the conclusion. The opposite of tomorrow is Thursday, and that is tomorrow is not Thursday. That would be technically the opposite of the conclusion. All right. Now, if tomorrow is not Thursday, I want to relate to Wednesday. If tomorrow's not Thursday, then today can't be Wednesday. If tomorrow's not Thursday, then today's not Wednesday. And that actually is, let me put it down on the next line, that is the opposite of P. Because P was today is Wednesday. And I just concluded Today can't be Wednesday. So I think I already did it. We start off with the conclusion, tomorrow's not Thursday. We were able to conclude from that that today can't be Wednesday. That's the opposite of P. So the opposite of Q does in fact imply the opposite of P. Therefore, we can say this original statement, if today is Wednesday, then tomorrow's Thursday, must be true. Let's see how they wrote it. Assume that the conclusion is not true, that tomorrow is not Thursday. If tomorrow's not Thursday, then today's not Wednesday. The contrapositive is true, so the statement must be true. There we go. All right, you can click pause if you want to try B, and then push play when you're ready. If a whole number is between 1 and 4, it's a factor of 6. If a whole number is between 1 and 4, the only whole numbers between 1 and 4 are 2 and 3. So P is, I don't know why I'm starting off with P, but P is if a number is 2 or 3. That's one way of thinking of it. If a whole number is between 1 and 4, that's saying that the number is 2 or 3. And why don't I just jump to, even though I'm doing it a different way than the last time, I'm going to do the opposite of P. The opposite of P. If a number is 2 or 3, so the opposite of P would be if a number is not 2 or 3. And I shouldn't have the word if. There we go. All right, what's this part? Whole numbers between 1 and 4. It is a factor of 6. So that would be a number is a factor of 6. And the opposite of that would be a number is not a factor of 6. All right, can I start with this Q part? A number is not a factor of 6. Okay, if a number is not a factor of 6, the only factors of 6 are 1, 2, 3, and 6. So if a number is not a factor of 6, it can't be those numbers. And right here it says a number is not 2 or 3. Yeah, I think that's it. Let me just see how they probably worded it better than I did. Assume the conclusion is not true. The whole numbers between 1 and 4 are 2 and 3, and both are factors of 6. And they were saying it's not a factor of 6, so it can't be 2 or 3. Yeah, so the contrapositive is true, and the statement must be true. Hopefully that was enough examples. Turns out this is the last section, so let me throw up the... We really only had 2 things we talked about. Indirect proof by contradiction, indirect proof by the contrapositive, where you have the P's and Q's, and there's the steps if you wanted to take a screenshot of that. Okay, now after example 3, you should be able to do these 7 problems, 23, 24, 27, 11, 13, 22, and 12. Thank you. Have a nice day.